to be a lot of thinking. Okay, so let's write down what we know. We know we're talking about a person's heart rate. All right, and I feel like part of what we need to figure out are what are the variables. All right, so they say that a person's maximum heart rate it is 220 minus x. All right, where x is the person's age. All right. What they also tell us about their age is they are between 20 and 65. So here is our variable x. Okay, that's the first thing. Okay, the next thing they say is when exercising, a person should aim for a heart rate, so a goal heart rate that is at least 70% of the maximum heart rate. And I'm going to say and at most 85% of max heart rate. So here is the given information. Okay, and so from here we're going to write equations for this. Okay. The question that always comes to my mind is, what is the other variable? How many of you guys were thinking that? What's the other variable? Okay. This is an indication of what the other variable is not. What does this say? And what does this say? What do those say? I mean, you can either read it to me or you can mathematically tell me what those say. Joseph? Yeah, this says 70% of the maximum heart rate. 85% of the maximum heart rate. What operation goes with of when it's after a percentage or a fraction? L? Multiplication. So we need to multiply 70% times the maximum heart rate and 85% times the maximum heart rate. This is when you're like, okay, well, what's the maximum heart rate? Well, the maximum heart rate is that expression. So while the maximum heart rate is not a number, it is an expression. So what that means is that the other variable is our goal heart rate. Because it's the only other thing we don't know. We have an expression for the maximum heart rate, 220 minus x, that has x involved in it. So while we don't know the maximum heart rate, we do have an expression that we can use, and we're using that expression in finding the goal heart rate. All right, so if I take what I know here, I have one equation which is this, and I would break that into two. So one of them, inequality, is going to be x is greater than or equal to 20. X is less than or equal to 65. So there are my first sets of inequalities. That's based on our age requirements. Next is based on these goal heart rates. Well, one of them is going to be y is at least, so that y is greater than or equal to 0.70 times 220 minus x, that quantity. And then the most it can be, so y is less than or equal to 0.85 times 220 minus x. So here are my inequalities. Okay, if I multiply that out, I end up with y is greater than or equal to 154 minus 0.7x, and y is less than or equal to 187 minus 0.85x. Those are the ones that we would use to graph. Now, here's the thing with the tricky part of so questions on the equations. Molly. I did the distributive property. I did the distributive property. So these bottom ones are what happens when I do the distributive property. Yep, so I had to do the distributive property. Now the tough part that I'm hoping most of you caught on to here was I have to coordinate my y-intercepts of 0, 154, and a 0 and 187, and I need to coordinate them with these slopes. So my slope here is 0.7. Well, that's the same thing as 7 over 10. That's also the same thing as 70 over 100. So that's how I can coordinate my slope with those. Off the top of my head, you could probably count by 2, 4, 6, 8, 10, 2, 4, 6, 8, 10. It's 9. You could probably count by 20s and still accomplish this. On my y, I could probably count by 20s. On my x, I could probably count by over 100. I could count by 20s on that as well. That would help. That would work. Okay? And that also would work for these. I can figure out where both of these are on my x-axis. That's probably what I would have counted by, I think. Just as a precursory, as I'm looking at this, a cursory thing, I'm pretty sure I would count by 20s here on both of them if I was using 70 over 100 as my slope. And that is what you guys kind of need to think about, is you have to coordinate those y-intercepts and those slopes. Okay? Does anyone need me to actually graph this? Okay. So this is slope-intercept. Now, one of the things I want to point out to you is pay attention to the signs of the slopes. It's very easy when I have a slope of negative, like say 70 over 100. It's very easy to think that I have a rise of negative 70 and a run of negative 100. So when I graph that, I actually have a positive slope. So when you get done graphing, I want you to think to yourself, my slope was negative, is this a negative slope line? Negative slope lines go down from left to right. Positive slope lines go up from left to right. So that's a quick double check to see, did I do my slope right? Okay, so keep that in mind when you've got negative slopes. A negative slope is only one of those is negative. So it's either negative 70 over 100 or it's 70 over negative 100. Whatever works. Okay? All right. Who asked me for that? Giselle, does that help you, sweetie? Awesome. What else can I do for you guys? Natalie, I know you were talking about graphing as an issue. Is there one that you want me to do that can help you with that?
No, I just think that I need to pay more attention to the signs of the shading and just
Okay. Is there one that you want me to do to help you with that, or are you okay?
No, I think it's
Okay. Rafaela? Where are you? What number are you on? Okay, so let me take a look at 40 here. Do you understand how, okay. Go ahead with your question. No, so you guys, I tried to tell you guys this yesterday. You do not need, for me, next year you might, for me, you do not need to give your axes as part of your inequality statement. So you don't have to say x is greater than or equal to 0, x is less than or equal to 0. If there's a limitation, if the length of the bat can't be lower than, well, for here, you couldn't have less than 25 age, then it would. But if it literally is just limiting you to what's in that first quadrant, I don't need that. Does that make sense? What else can I do for you guys? Yes? I take a look at 40, 40 says to us that we have sheets of pictures. All right, they are $8 per sheet. All right, they tell us that we have a sheet, so we have a sheet with 4 3-inch by 5-inch pictures. And then we have a sheet that has 2 4-inch by 6-inch pictures. So we have 2 different options of sheets. So this is option number 1, this is option number 2. So Anastasia, are you good with the 2 different options? Awesome. Okay. They tell us that is the cost that we each of them, no matter how many pictures you put on there, it's always $8 per sheet. Okay. So then in part A, it says you want at least 16 pictures of any size. So we want a total of at least 16 pictures. All right, and it says you're willing to spend up to $48. Okay, so here's one of my totals. Here is my other total. All right, so at least 16 pictures. All right, well, let's think about how many pictures fit on a sheet. So first of all, because my cost is per sheet, I need to know how many sheets of the number 1 option I'm going to have and the sheets of the number 2 option I'm going to have. So I'm going to say that X is my number of option number 1, and Y is going to be the number of sheets. The number of sheets of option number 2. So that I'm going to set. Sometimes finding the variables can be the hardest part on these. So I would look for your rates. They will help you. I would look for the different things that you're measuring. Last one you were measuring the number of your age and then your heart rate, the aim heart rate. All right, so find those variables. So now I'm going to use my totals. Okay, so if I need 16 pictures. Well, how many pictures are there on each sheet of my option number 1? How many pictures are there, Rita? There are 4. So if I have 4 pictures from my first sheet, plus, how many pictures are on my other sheet? Lily? 2. So I have 2 pictures on option number 2. So 4 times however many sheets I have of that first option, plus 2 pictures however many sheets I have of option 2. That has to be at least, so greater than or equal to 16. So that 16 is the minimum. Ours has to be at least that amount or more than that. Natalie, is that part of the hard part? Okay, so when you have your totals, kind of think about, is our total a maximum or is our total a minimum? What we are measuring, what we are doing, what can that be in relation to that number? All right, so at least it has to be that, so that must be a minimum for what we're doing. All right, I want to spend up to $48. So what that means is that $48 is our max. All right, so whatever I'm going to be doing is going to be less than or equal to that $48. Okay, so now let's do the actual math for money. Well, I know each sheet is $8. So $8 times the number of sheets for option 1, 8 times X, plus $8 times the number of sheets for option 2, that has to be a maximum of $48 or less than or equal to $48. So there are my 2 inequalities. All right, I would not write X has to be greater than or equal to 0 and Y has to be greater than or equal to 0. I'm not interested in that. I'm more interested in this. Next year in higher up math, they may want you to put that limitation on there, but I just want you to worry about this stuff. I'm always going to say to you, can it go beyond the axes? And you should know whether your information can go beyond the axes or not. Okay? That's always what I'm going to ask you. And that takes care of that X is greater than or equal to 0 and Y is greater than or equal to 0. Okay? Yeah. Spit it out, dude.
So, we use substitution and elimination.
You can only do graphing. Great question. Okay, so let's think about that for a second. For when you use substitution or you use elimination, what are you actually finding? You're finding exactly what x is or exactly what y is, right? Is there an exact x or an exact y for these? No, it's a range of possibilities. So you can't, the only way you solve a system, either a linear inequality or a system of linear inequalities is only by graphing. Because there's a whole variety of possible solutions. Okay, it's a good question. Graphing is the only way. All right, are there any other problems from the homework that I can do for you guys? Okay, get your notes out. Let's just do a quick review of our chapter. And if we have time, I will take any other questions, any concerns, anything that you guys have. Go get some lead. Do you have lead at home? No. Do you have lead at home? Yeah. I get like packs of lead that have like the big jumbo ones in them because I go through so much. Throughout the whole year, I go through so much. Okay. So this is a pretty limited chapter. There's not a lot that's going to be on this chapter with regards to number of problems. It's just going to be a lot that you have to do for each problem. Okay, just like your homework quiz. That homework quiz was 33 points, and you guys had 2 problems. Okay, so this is our chapter 6 test summary. Okay, so the first thing in 6.6, in 6.1, we talked about solving linear systems. By graphing. All right, the one thing that I will say to you that I do require is no matter what form you get it in, no matter what format your equations are in, you're graphing from that format. Okay. All right, so you must graph the form you write. So if you have standard form, you're graphing standard form. If you have slope-intercept form, you're graphing slope-intercept form. I know that you can change your standard form into slope-intercept. All right, I know you can, but I want you being able to graph both. I don't want you losing that skill. That's the one requirement that I have. Okay. In 6.2, we were solving linear systems by substitution. I feel like that's my least favorite because I feel like that has the most work that goes with it. All right, I'm going to write a little note here. This easier to use when one equation is already solved for one of the variables. I feel like that's kind of what I would say. When one of the equations is already solved for one of the variables, or you have like a standard form equation and a slope-intercept, or two slope-intercept, I feel like solving by substitution is easier because there's not quite as much work to do. All right, 6.3 and 6.4. This was solving linear systems by elimination. That's my favorite. Like if I was to choose any of them to be like, that's the easiest way, in my opinion, that's the easiest way. And remember, the key is to get one set of variable terms as opposites. My goal right now is that when I'm reading this to you, that you guys are like, yeah, I already knew that. That this is not new. You aren't worried about this. All right. From there, 6.6 was just 6.6 was talking about special types. God bless you. Who needs to see what's up there? Okay. 6.6. These were special types of linear systems. This is where we looked at a no solution. Yeah. Oh, 6.5 was special types. Thank you. I would have figured that out when I looked back at my book. 6.5 was special types. No solution. What does that mean if we have a no solution? What does that mean about our solution? So if we're mathematically, so if we use elimination or we use substitution, what does that mean about our solution? Al? Yeah, it means like 0 would equal 5. All right. Your variable, the variables, both are eliminated. From a graphing perspective, what would the solution look like if it's a no solution? Giselle? Yep, we have parallel lines. All right, the other one is infinite solutions. So mathematically, what does that look like? Mathematically, what does that solution look like? Ashley? Yep, 0 equals 0, or 5 equals 5. All right, but again, on this one, the variables both are eliminated. So in no solution and infinite solutions, that is still the case. Both sets of variables, the variables go away. Variables both are eliminated. If a variable's left, you do have one solution. All right, from a graphing perspective, what does that solution look like? Rita? Yep, they're both the same line. If I gave you a story problem for either one of these, when we talk about it from a story problem, if you get to a point where you have a no solution or an infinite solutions, the variables go away, you're simply going to say, not enough information. That means someone could have used a coupon. There might be a special involved if you buy more than a certain number of things. If you stay for 7 nights somewhere versus 3 nights somewhere, you might get a discount along the way. There might have been a one-time, I don't know, there might have been a reward for staying. All right, so you just don't have enough information. All right, the last thing we did was systems of linear inequalities. All right, and the only way to solve is graphing. All right, we always look for the overlap in the graphs, or the shading, overlaps in the shading. That's it. You have no more than 4 problems tomorrow in your test. So you'll either have 3 or 4 problems. That's it. You're going to need a ruler. You may have your calculators